Thanks for watching another video from weldingtipsandtricks.com. This is part 2 of two-part video series on comparison, on demonstration of the Miller Diversion 180 and the Everlast powertig 185 micro. Both these machines are kind of stripped down as far as controls go, but both of them weld pretty good. You remember last week's video, we did all kinds of different little welding scenarios, welding on thick steel, welding an outside corner joint here on really, 18 gauge thin carbon steel, and also we welded some aluminum, and both machines performed very well. Some slight differences, some did better, one did better on one thing, one did better on the next, but both performed very well until we got out the really thick aluminum. Had some really thick stuff laying around, 1.5" solid round stock and some 1/4 inch flat bar, and both machines stumbled on this. They both just took about a good 30 seconds to even puddle that thick 1.5" round stock, and you just had to wait around, and so it's, no surprise because neither machine was rated for that thick. But how do you do that? How do you increase the heat without having to buy a new machine? Well, helium is the way to do it. Without helium, both machines had to be maxed out and took forever to get a puddle going. With helium, turned both machines into a beast. This is the Everlast. It's maxed out at 185 amps, but this is really thick stuff. This is 1/2 inch aluminum welded to 1.5" thick. No preheat, just took a few seconds to get the puddle going, and now this is pushing the limits. This is way beyond what the machine is designed for. I'm just showing you what the addition of helium will do, and that's what this video is about. It's some practical tips. A Western part number 411Y with valves is what you need. You can get that at weldfabulous.com, probably several other places, but that was one place that I did find it available. I also need check valves because your pressure is going to be different on your helium and your argon. You don't want to mix it accidentally or inadvertently within your tanks. Check out my old school regulator flow meter. I've had this thing like 30 years, still kicking. Big Airco, big massive thing. All right, what percentage helium do you need? It's not rocket science. Anywhere from 50 to 80% works great. The higher, the better. Up until about 80%, you start losing arc stability and arc starting. But the more up to 80, the better. A guy sent me this an email asking me about welding on an automotive aluminum rim, and I had no idea how big the hole was in it. He said it was close to 2 inches, and so I gave him some advice, and not necessarily condoning the repair as far as whether it's safe or not, but I gave him some advice to use copper backing to trap the argon and to support the weld metal. And he had already bought a TIG finger, and he just really bragged on how well the TIG finger worked. You can imagine how hot this thing got with all these beads he put on it. And you're able to prop right on that metal with a TIG finger with no problem. But you can see he's got a big bar of copper clamped to the back, and what that will do is not so much chill. What that'll do is it'll support the metal, and it'll trap argon, so it'll make everything go better. So you can see he's welded one round all the way around it to kind of melt the edge in, and then he just started closing it up from one side, running bead after bead after bead. Now you don't want to just continuously weld this thing. You want to let it cool for a minute or two between beads, but gradually, just bead after bead, you can close a weld like this and fill up a hole. And this guy did an awesome job on this thing. And with that copper on the back side, it lets the metal sink through just a little bit because it's not actually touching. And then all he had to do was a little touch up on the back, and now he's got a good weld repair, and it's going to hold air again. You remember last week's video, we talked about using copper backing for filling holes in some thin stainless steel, and how it traps argon and also provides a heat sink. Well, it works good on aluminum as well, and this particular job, it worked really well. Here's the little repair filling the hole on stainless steel. A small hole like this, there's no point in stopping. You just fill it all in at once, but it traps argon on the backside and is almost as good as having argon shielding on the backside. So that's the stainless steel hole repair, and the same thing applies on a much bigger hole on aluminum. He's got copper backing clamped on the backside, and it's trapping the argon, and it just takes a little bit longer. A lot more passes, a lot more stopping, and letting it breathe a little bit. but still works really good. So again, with the copper backing on the backside, supports weld metal, and just sometimes you don't even have to touch it up on the backside. All right, well that's it for today. Thanks for watching weldingtipsandtricks.com.